Bienvenidos, Ushamdid, and welcome Anne Arundel Community College learners from the CTS-131 Section 402 course for the spring 2021 semester. This is the Cisco Networking Academy's Switching, Routing, and Wireless Essentials version 7 course curriculum. And in this packet tracer tutorial and activity, we're going to be taking a look at packet tracer 3.4.5, where we're now going to be configuring trunk links. So let's go ahead and dive in to the topology. And this topology should look very, very familiar because it's the exact same topology that we just configured the VLANs in for activity 3.3.12. In this scenario, we're going to verify the VLANs and configure some trunk links. Now, remember, the definition of a trunk link is a link over which multiple VLANs are allowed to transit. And by default, all VLANs are allowed to transit trunk links. And as we move through the course curriculum, we'll talk about scenarios where you would want to limit the allowed VLANs. All right, so let's dive in here. And first, we're going to go ahead and verify that the VLANs exist. And so we're going to start here on switch 1. And they want us to run a command that's going to show the VLANs that have been configured. So we're going to go from user exec mode with the enable command into privilege exec. From here, we're going to say show VLAN brief. And as we can see, we now have a native VLAN involved and a management VLAN that are separate from each other. So VLAN 88 is the management VLAN and VLAN 99 is going to be the native VLAN. So there should be 10 VLANs in total. So we have VLAN 1, 10, 20, 30, 88, 99, and then 102, 3, 4, and 5. And so that gives us the 10 VLANs that we need. Now, remember, we talked about, notice that all 26 access ports on the switch are assigned to VLAN 1. And we can see that right here. And remember, we see all 26 ports, the 24 fast Ethernet ports and the 2 gigabit Ethernet ports. On switch 2 and switch 3, we're also going to display and verify the VLAN information. And let's go ahead and say show VLAN brief. And do we see all 10 VLANs? We do. And then we'll take a look over here on switch number 3, say show VLAN brief. And we do see all 10 VLANs. Now, what's different is that switch 1, all 26 ports are assigned to VLAN 1. However, on switches 2 and 3, and I'm going to step back to switch 2 here in a second, you'll notice that we have ports that are assigned to specific VLANs, or you could look at it as VLANs being assigned to specific ports. The idea being is that we're creating a VLAN, a subnet, a broadcast domain. Remember that a VLAN is a subnet, is a broadcast domain. And that's exactly what we're doing when we create VLANs. And the problem we ran into in the previous activity, 3.3.12, was that we had the VLANs created and we had each of the individual ports assigned to the correct VLAN, but we finally realized that there were no trunk ports configured. And so communication would not work from VLAN 10 on the left-hand side, PC1, to VLAN 10 PC4 on the right-hand side of the diagram. And that's because the only VLAN that was allowed to transit these trunk links at that I should say those links before they became trunk links was VLAN 1, because the dynamic trunking protocol DTP on Cisco switches, on current Cisco switches, is set to dynamic auto for all ports on the switch, meaning that if both sides are dynamic auto, no trunk will form. In fact, what will form is an access port. And we're going to see that again with that very, very informative command, show interface, the interface gig00, fast Ethernet 01, whatever the interface is, switch port. And that's going to provide us a really nice look into how those ports are actually operating. Now you can also see here on switch 2, we've got everything lined up. So fast Ethernet 06 is VLAN 30, 18 is 20, and 11 is VLAN 10. So verify loss of connectivity between PCs on the same network. And that should be easy enough to do. And actually, before we do that, let's come to switch 1, sort of the central focus point here of these trunk links. If I say show interface trunk, so show me the interfaces that are trunk links. If you get nothing back, that means that you do not have any operational trunk links on the switch. And so let's actually take a step back here. Let me digress for a second. And we're going to say show interface gigabit Ethernet 01 switch port. And you can see here that the administrative mode, and that is the default mode, is dynamic auto. And you can see here the switch port's enabled. And what did it finally decide to become? The operational mode is static access, because both sides are dynamic auto, meaning both sides are kind of standing there looking at the other side saying, well, do you want to be a trunk port? Because I'll do it if you want to do it. But they're both saying that same thing. None of them is saying, hey, we're going to be trunk ports. That would be dynamic desirable. Or we could have it hard-coded as a trunk port with switch port mode trunk. Now, Cisco best practice is to hard code, if it's going to be a trunk link, hard code it as a trunk link and turn DTP, the dynamic trunking protocol, turn it off. And so we're going to see that here shortly. All right, so we're going to test connectivity first. I had to step back there real briefly just to talk about that. And we're going to say from PC1, let's ping 172.17.10.24. And again, the connectivity is not going to work. We know it's not going to work. And really, this activity sort of picks up where 3312 left off. We resolve 3312, right, as part of, hey, let's talk about this and let's get it configured. And so now we're basically going to do it again. So we're going to configure trunk links. We're going to do that on switch 1 first. Now, we can do the interface range command here, right? It could save us some time. So let's go from privilege exec mode, as evidenced by the # into global configuration mode, where I can make global changes. And in fact, we're going to say interface range gigabit Ethernet 01 to 2. And so now I am changing the configuration for both gigabit Ethernet 01 and 02 at the exact same time. So the commands I enter in right now will apply to both of those ports. So I'm going to say switch port mode trunk. And now we're going to do a command that's not listed here, right? And you'll notice we're getting this native VLAN mismatch. Or we're about to get this native VLAN mismatch. But before we do that, what I wanted to say was what we're going to have happen here is we're going to issue a command, switch port no negotiate. That is what disables or turns off DTP. And so before I hit enter, if I roll back up here, remember, you can look right here and it says negotiation of trunking on. That is telling you that the dynamic trunking protocol is on this port. DTP is running. We don't want that, so we say switch port don't negotiate. So don't do the dynamic trunking protocol negotiation. And now we say do show interface gigabit Ethernet 01 switch port. And we see something much different here. We see that the negotiation of trunking has been turned off. And that's what switch port no negotiate facilitates. That is a Cisco best practice when hard coding a port as a trunk link, because we don't want it to negotiate. Again, you want things to be predictable. You don't want to leave things to guessing. And an example of that is the confusion. Just look at the confusion that learners have when you see two links plugged in between switches and everyone assumes, oh, that's a trunk link. Well, no, it's not, because it's dynamic auto on both sides. So let's make it predictable, because no one likes surprises in their network, right? So hard-coded as a trunk link, turn the dynamic trunking protocol off. Now what we're going to do is we're going to choose a VLAN other than VLAN 1. And you also saw right up here, so we're still on this do show interface gigabit Ethernet 01 switch port command. trunking native mode VLAN. In other words, which VLAN am I going to tag frames that show up on switch number 2 that are untagged that need to transit across this trunk link? And so maybe the scenario is, and this is a unlikely scenario, let's leave it at that, but what if this is a hub? Right? What if this is a hub? And off of this hub, we've got all these PCs here, right? If this traffic is trying to make its way across that trunk link, it could show up as untagged. And so we would need to tag it with the native VLAN. That is the function of the native VLAN. It is used to tag traffic that is going to transit the trunk link and doesn't have its own tag. It doesn't have a VLAN tag. So we use the native VLAN to accomplish that. So let's go ahead and say switch port trunk native VLAN, VLAN 99. Now we should see here shortly that the Cisco Discovery Protocol, CDP, is going to show us a warning message telling us that we have a native VLAN mismatch. And we may be seeing that over here on these other switches. And what do you see happening here? We haven't talked about spanning tree yet, but spanning tree is now blocking gigabit 02, traffic from gigabit 02 or on gigabit 02. And so this is the result of a native VLAN mismatch. And that's what we've got going on here. And you can see that right here, CDP, native VLAN mismatch. And the message gives you all the information you need to resolve the problem. You can see here it says the mismatch is on gig 01, where we have one set, right? With switch 1, gigabit Ethernet 01 is 99. So we're getting one from switch 1, right? I'm sorry, from switch 2, because that's the switch connected on gig 01. So that's the incoming tag, or that's the incoming setting that we see. However, on our switch, on switch 1, gigabit Ethernet 01, it's set to 99. So there's the mismatch. And now traffic will be blocking, or will be blocked on this port until we resolve this issue. And so we're going to sort that out here in just a second. And that actually takes care of, so we have a native VLAN mismatch. Pings between PCs on the same VLAN are successful, right? And explain what's going to happen. So we've got this native VLAN mismatch. Let's pull this up, excuse me, and let's run this command. And again, the reason it's successful is because we've got this native VLAN mismatch. We've got the blocking message that's coming up, but it's blocking VLAN 1 and 99. These are in other VLANs. And therefore, that communication is going to be allowed. And again, it says here, you configured VLAN 99 as the native VLAN. However, switch 2 and 3 are still using VLAN 1. Although you have a native VLAN mismatch, pings between PCs are now successful because it's blocking that traffic for VLANs 1 and 99. In fact, if we were to come up here real briefly, and I was to say, do show spanning tree, you can see here that for VLAN 10, and again, we haven't done spanning tree yet, so don't panic, but I'm just showing you why that traffic is functional for us. Whoops. And so you can see we're going to continue to get these messages scrolling here. So for VLAN 20, it shows us that it's forwarding. For VLAN 10, it's forwarding. And we see here for VLAN 1, it shows designated forwarding. However, we're not sending any traffic on VLAN 1 or VLAN 99, which is why the traffic is allowed to transit that trunk link. So now let's verify if trunking is enabled on switch 2 and switch 3. In fact, if I say here, let's save our config, write mem, and say show interface trunk, you can see that this shows that trunking is on, meaning I've hard-coded it. It's not negotiated. The encapsulation is the default encapsulation, 802.1q, and there's our native VLAN 99. And you can see the VLANs that are in the forwarding state and allowed to transit, or I should say, and not pruned, right? And we're going to see some additional output here in a second. So let's come over here to switch number 2. We'll go from user exec to privilege exec. Let's get into interface, let's get into global config first. Interface gigabit Ethernet 01. We'll say switch port mode trunk. And then we'll say switch port trunk native VLAN 99. And then we're going to say switch port no negotiate. Right now, take a look at that. The VLAN 1 and VLAN 99 port consistency has been restored. You'll notice it doesn't say anything about VLAN 10, 20, 30, and we haven't done anything with 88, and I don't think there's nothing going on with 88 here, but 10, 20, 30, right? It doesn't say anything about inconsistency there. What it says is VLAN 1 and VLAN 99, that we are now unblocking, right? And that the consistency for those ports has been restored. So now here, let's go ahead and save our config just in case and say show interface trunk. And now you can see that on gig 01, the mode is on, the encapsulation is .1Q, which is the default and the only trunking encapsulation that we use between Cisco switches, right? And then the status is trunking, and it shows us our native VLAN. And again, we see which VLANs are allowed. Again, by default, all VLANs are allowed to be forwarded across a trunk link. And now let's come over to switch number 3, and we're going to do the exact same thing. We're going to get into, and I think I'm kind of doing this out of order, and that's okay. So we'll get into global config, interface gigabit Ethernet 02, switch port mode trunk, switch port no negotiate, switch port trunk native VLAN 99. And again, the reason we don't want to use VLAN 1 is due to security, right? Because there are some exploits or vulnerabilities with using VLAN 1 everywhere, which is why for your data VLANs, you typically pick a different VLAN other than VLAN 1. And so now everything is up here. Let's save our config and let's say show interface trunk. Show me the trunking interfaces, and everything looks good. So now let's come over here. Let's retest this, and this should work. Let's test from PC2 over to PC5. And let's go ahead and say ping 172.17.20.25, and that works. And then finally, VLAN 30. And let's take a look here. And let's go ahead and say ping 172.17.30.23. And that works like a champ. And so let's just take a look. We've got 100% here, but let's make sure we address any questions that are here. So issue the show interface switch port command. And that's something that we haven't done, so let's go ahead and do that. We'll do it on switch 1. And let's say show interface gigabit Ethernet 01, switch port. And take a look. Remember, we talked about this earlier. Trunking native mode VLAN is 99. And look at the administrative mode, right? It says trunk, meaning we have hard-coded it as a trunk. There's the operational mode. What is the port actually functioning as? It's functioning as a trunk port. What about our encapsulation here? .1Q, 802.1Q. Did we turn off DTP? We did with the switch port no negotiate command. And so hopefully that gives you a good feel for trunk links, how to configure the trunk links, and some of the Cisco best practices around making that happen. All right, well, that is going to do it for this Packet Tracer tutorial and activity on Packet Tracer 3.4.5, where we were configuring trunk links. Thank you guys so much for watching. Let me know if you've got any questions, and I hope to see you in the next video.